The diagram shows a uniform metal bar of mass 20 kilograms and length 2 meters freely hinged to a vertical wall and held horizontal by the force P, which acts at 30 degrees to the horizontal. We want to find P and the reaction at the hinge. The mass is 20 kilograms and we have a uniform bar. Therefore, the weight of 20 G acts at the center of the bar. The force P possibly needs to be resolved here. So let's go P cos 30 in this direction, cos 30 because it's adjacent to the angle, and P sin 30 in this direction. Once we have these, we can ignore P, since the components do the same job. The other thing we have is a reaction at the hinge. The way to deal with this is to consider the reaction at the hinge has two components. We'll call them X and Y. So X is a horizontal force and Y a vertical force, and these two forces, when combined, give us the reaction at the hinge. It doesn't matter if we get X and Y in the wrong direction. This will come out in the mathematics via a negative answer. A negative answer would indicate that the force actually goes in a different direction to the way it's drawn on the diagram. Let's call this point A and take moments about A. Remember, if we are in equilibrium, the resultant moment about any point must be 0. A is a convenient point to choose, since this component here has no turning effect about A. We can see its line of action goes directly back to A, and also the X and Y have no turning effect about this point. We have two forces now which do have a turning effect. The 20G turns clockwise and the P sin 30 anti-clockwise. 20G times its distance must be equal to the P sin 30 times its distance. So here we have 20 times 9.8, which is 196. Sin 30 is a half, times the 2 means these cancel, and so we've found that P is 196 newtons. Since we're in equilibrium, horizontal forces must balance out, so P cos 30 must be equal to X. If X is equal to P cos 30, and we know the value of P, we can calculate the value of X, and we get 169.7 newtons, correct to 1 decimal place. If we look at the vertical components, we must have the forces up, the P sin 30, and the Y equal to the force downwards. So Y plus P sin 30 would be equal to 20G. This means that Y is equal to 20 times G. Take away the P sin 30, 196 times sin 30. And calculating this gives us 98 newtons. X and Y both turned out to be positive, which means they're in the same direction as they were drawn on the diagram. X therefore is 169.7 to the left, and Y is 98 upwards. The reaction itself is the third side of this right-angled triangle, so we want to find theta and r. For r we can use Pythagoras' theorem. R will be the square root of 98 squared plus 169.7 squared. And this is equal to 196 newtons. Theta is going to be the inverse tangent of the opposite over the adjacent. When we calculate this, we get 30.0 degrees to three significant figures.